In a previous video, we worked on going from a problem statement of the pencil production problem to a mathematical model to represent it. And so I'll link to that video in the description, but basically what we did was we had a problem statement that you can see here where I'm working in a small factory. I'm making two types of pencils, the economy writer and deluxe pencils, and I want to figure out how many of each type of pencil should I make in order to maximize profit. And I need to do it in such a way that I do not violate both labor as well as material constraints. And if you remember, we went through the process of developing a mathematical model, and we ended up with something that looked about like this on the right hand side, where we were going to maximize some objective function which describes the overall profit that would be generated, subject to a listing of constraints where the first four of these constraints have to do with department level labor constraints, and the remaining constraints have to do with the inventory of each component. And we stopped the video at that point. But of course we want to use this mathematical model and actually solve it. And so the nice thing about these mathematical models is that different institutions, different companies, different people have come up with these solver packages that you can use. So you don't have to necessarily solve them always by hand, or very rarely do you actually solve them by hand in practice, but you actually will describe the mathematical model to this solver and then allow this solver to solve it for you. And one of the ways you can do that is in MS Excel. The default Excel installation will have a solver embedded inside of it as an Excel add-in. And so if you have that add-in active, you can go to the Data tab, and it will be right under here under the Analyze partition of the Data tab, and they'll have Solver. And we'll get to this part a little bit later, but basically what you do is you describe the different pieces of the mathematical model to the solver through this interface. Let's say you don't have this showing in your installation of Excel. Don't fret. You can go to File, go down here to Options, Add-ins, and this is where you manage the Excel add-ins. In this case, I have the solver add-in active. If it wasn't up here, let's say like this analysis tool pack, it's listed under the inactive add-ins, then you can just click on it, go to Glue, and then click the corresponding checkbox here and hit OK in order to load that add-in. But of course I've already got it added in, so I'm ready to go. So then of course you need to start with a worksheet to start putting in all your data. And so that's what I've done here. I've done a little bit of prep work in order to decrease the length of this video. On the left hand side of this black column, you can see I've just loaded in all of the data from our problem statement. And I've also done a few things that you can see in the dark gray. Typically they had to do with unit conversions. If you remember right, when we talked about time in terms of labor, we had a shop labor rate in minutes, we had the time taken in each department by each product in seconds, and then we had a capacity in hours. So I went ahead and converted everything such that I have a common unit of time of hours in these dark gray cells. Similarly, we had some issues between the bill of material and the part inventory tables. The part inventory tables was referencing things in weight at times, and these were typically in ounces. So I went ahead and converted them to pounds just by dividing by 16, as you can see in the function bar. So now that the data is all accessible to Microsoft Excel, the next thing will be to actually describe the model for Excel, and that's what this right hand is going to be used for. And I'll just use this screenshot of my mathematical model for reference. So the first thing I need to do is have a place for Excel to be able to store the decision variables. And that's what I've got right here. So each one of these two cells will represent the quantity of either economy writer pencils that I'm going to make or the quantity of deluxe writer pencils I'm going to make. And then I just need to work kind of from top to bottom here and develop the rest of the model. So if you remember from the previous video, the unit profit contribution had a few components to it, right? We had to figure out what the total revenue is and the total material cost and the total labor cost as well. So I've broken that up into at least two sub-calculations for the unit material cost and the unit labor cost. So I guess we'll just work left to right here. First thing is to calculate the unit material cost for every economy writer pencil. And so if I look at the way I've got my data laid out here, I've got the bill of material for a economy writer pencil in this row, and then I've got the unit cost associated with each part in this row here. And notice the order is also the same: cedar blank, glue, glue, so on and so forth. And so what I would want to do is take this value times this value, right? That would be the total material cost tied in with the cedar blank, plus this value in the glue times the corresponding unit cost of the glue. That'd be the amount of cost tied up with the glue, so on and so forth, right? I'm going to take the product of each one of those, and I'm going to sum all my products. Well, thankfully, Excel has this built-in function called SumProduct, which will help me do this. And so what I can do is select the two arrays. So this will be the first array. I can hit a comma. This will be my second array. And it's going to do just what I described. By position, it'll take the product of each element in the array, and then it's going to sum all of those products. And I'll do the same thing now for the deluxe writer, which is going to be very similar, except I just need to make sure that my bill of material is on the deluxe writer row. And it appears we've got a little bit of an issue. Try that again. SumProduct. All the deluxe writers, comma, all the unit costs. Very good. Scared me a little bit there when that value is bigger than my sell price, so I knew there was a little bit of an error. But 42 cents and 64 cents, it appears to be the material cost for each of the economy and deluxe writers, respectively. So now we move on to the unit labor cost. So the unit labor cost is basically the total amount of time of labor times the shop labor rate. And so it looks like here is the total amount of time for the economy writer pencil. If I just sum how much time it spends in each department, and then I can multiply by the shop labor rate and do the same thing for deluxe. So I will just sum this column here and multiply the shop labor rate and do the same thing for the deluxe writer. Okay. And next for the unit profit contribution, I haven't explicitly shown the revenue, so I'll just tie that in here. The profit for the economy writer would be the total sell price of the writer minus the sum of the material and labor costs. And I'll do the same thing for the deluxe writer. Okay, looks like we're on the right track. Notice these two values, 41 cents and 84 cents, are the same values that we came up with earlier in our objective function. So at this point we've computed those two values, and now we need to describe the objective function to Microsoft Excel. And so I'll use this yellow cell here for that, and we'll just say this is the unit profit contribution for each economy writer pencil times the quantity of the economy writer pencils that we're going to make, and then plus the same thing, the unit profit contribution for the deluxe writer pencil times the quantity of deluxe writer pencils that we're going to make. And so this yellow cell is now representing this line in my mathematical model. So down here is where I usually will place a table for constraints, and so the constraint table is basically made up of a column to store my left-hand side, so everything to the left of the, in this case, all inequalities, but it could be equalities as well. This middle column here represents the equality or inequality. This column here, of course, is the right-hand side constants in this case. And then I usually try to put a comment block here just so I can keep track of what each constraint is representing. So for instance, the first 4 constraints that we have to do with the pre-processing department labor, the curing department labor, shaping department labor, and assembly department labor. So if I go ahead and fill out the right-hand sides of each one of these, so there's the total capacity in terms of labor for each department. So I'll say equals and reference them right from the data tables. And so I like to do this just so if I want to play kind of like what-if scenarios and make changes, I can go right to the data table, make the changes there, and not have to be updating 2 different parts to keep everything in sync. And so each one of these is a less than or equal to, so I usually just shorthand note that like this to say less than or equal to. And then the left-hand side needs to be the total amount of time consumed in each one of the departments, exactly what I have here. And so for the pre-processing, it would be the economy writer pencil time times the quantity of economy writer pencils plus the deluxe time times the deluxe quantity of pencils. I notice I'm pulling again from the hours columns there on the left hand side to make sure my units match in this quantity, so I can have hours here and hours here. And I need to do the same thing now for each one of the other departments, so I'll quickly do that. There's the curing department. Here's the shaping department. Correct my typo there. And finally, the assembly department. Okay. So with any luck, we've already taken care of the first 4 constraints, and then the remaining constraints were all tied into material inventory. So we'll just say this one's going to be for cedar blank, glue, basic lead, smooth lead, matte paint, wood stain, the ferrule, the eraser, and the grip. Each one of these is also going to be less than or equal to, so we'll go ahead and put that in place. And again, let's go ahead and just populate the right-hand sides with the inventory values. Okay, we've got those all in place. And next we will formulate the left-hand sides of each one. And so the left-hand sides will be kind of similar to the way we did the labor. We just need to figure out how much of each one of these parts is consumed by our production plan. So for cedar blanks, we'll have this value times this value. So we take the number of cedar blanks consumed for every economy writer pencil times the total quantity of economy writer pencils there, less the number of deluxe writer pencils times the amount of cedar blanks consumed by a deluxe writer pencil times the quantity of deluxe writer pencils there. We could do that for every single one of them, and it looks like that would be a little tedious. This is where this type of formulation yields itself well to the sum product, especially since both of these columns are vertical. And so I'm just going to use that sum product here to do this and this, and hopefully save me a little bit of typing. And so if now for the glue. The basic lead, notice I can use that same formula, and that 0 there for the deluxe rider will make sure that none of it is consumed with the creation of deluxe rider pencils. Smooth products, same thing, except now the economy rider pencils will be taken away. And we just work our way across the bill of material row, essentially. Wood stain. You do have to be careful. It's very easy to reference or pick a incorrect cell, and of course that's going to throw your model off that you're creating inside of Excel. So you have to watch for those type of errors. It's also one of the parts where I kind of see Excel as a downside, is having to manually create all of these constraints. When you get into practice, some of these models can be quite large, so it'd be very tedious to use Excel to solve them. Okay, so with that being said, we've now written constraints using that sum product function over and over again, which on the left-hand side should be the amount of each component that we're going to consume out of inventory, and the right-hand side are the amount of supply that we have in inventory. So at this point, we have everything in place that we should be able to pass the model to the Excel solver. So we can go to Data, Solver. If I slide this over to the left, the first thing it wants to know is where's the objective function. So we'll just click here and set it to that yellow cell. What is the type of objective function? Are we maximizing it? Are we minimizing it? Are we trying to attain a certain value? Well, in this case, we're maximizing it, so that's fine. Subject to some constraints. That's these constraints here. And typically, this will be empty, so I'll take that out. We need to add in these constraints. And so what this is you just hit add. This is the left-hand side, this is the right-hand side, and this is the inequality, equality. You can have an integer, you can make it binary, or do some diff. I think it stands for different. As you can see, I've actually never used this one. Binary is nice when we get into kind of things that are decision-based. Integer is just what it sounds, forces something to be an integer. But for us, we're consuming the decision variables are continuous and real, so we'll just need actually just this one. Another nice thing about the way this problem is set up is they're all less than or equal constraints. So what I can do is actually load all these in at once. If there's a mix of less than or equal to, greater than or equal to, obviously you have to load them in separately. So I can just select that entire range there to be the right-hand side. I'll select this range here to be the left-hand side. And so Excel knows that it needs to go kind of row-wise in order to evaluate that information. So this all looks good. We want to make unconstrained variables non-negative. That's basically enforcing this very bottom line of our mathematical model on the right-hand side. And then we need to select a solver. And in this case, we'll just select the Simplex LP solver since we're using this as a linear program. And we don't really need to worry about any of the options in this video. And so we just hit solve. Should solve relatively quickly, which it does. Pop this statement up. Solver found a solution. All constraints and optimality conditions are satisfied. If you want, you can show some of the reports, and I guess I'll just go ahead and expose those reports for now. It'll expose those in different sheets. And I'll make a separate video to describe what is going on with these sheets here. It has to do with sensitivity analysis with respect to our linear program. So the solver actually solved, and then it placed in specifically these cells here and this cell here the results. It basically went through, solved for the optimal solution, which included approximately 1,721 economy writer pencils and 5,102.6 deluxe writer pencils. This yielded an overall profit of $5,008.31, which does appear to be the optimal solution that I had in my notes for the problem. So that makes me feel good, that the fact that we didn't have any errors as we set this up in Excel. And again, we are assuming the decision variables are continuous reals, so that's why you're seeing fractional values of my decision variables up here on the right hand side. So hopefully this all made sense. Showed you how to go from a mathematical model of the problem to an implementation of it and a solution of it in MS Excel. And again, I'll make some follow-on videos which will describe what's going on in these other sheets that we exposed with the reports.